In this video, I'll be showing you how to use the Simpson's 3/8 rule to numerically integrate a function. Before we proceed, I recommend that you copy these tables down, or you can also download the Excel file. And this is just so that when you're inputting formulas or values, it makes it much easier for you to follow along with the video if you're using the same format. Here, we're asked to find the integral of the function 5 plus 3 cos x, and we're asked to integrate from 0 to 0.5. We're also given the Simpson's 3/8 rule formula. Now, what you might notice here is that we have 4 different points that we need to find in the formula. So we need point f of x0, point f of x1, point f of x2, and point f of x3. And so even though we're planning to integrate from 0 to 5, we need to establish 4 separate points. And so let's start off by answering or inputting values in this first table here. So first, we have to find the valuation of the function at each of these points. Now, the evaluation is simply just taking the original function and replacing the x values with our x values here. So it's simply just 5 plus 3 times cos x. And x in this case is replacing the x here with 0, like this. And we can copy down this formula to the cells below by pressing Ctrl D. So what we're doing here is simply just evaluating this function with our different points, as shown. Once we've done this, we can now utilize the Simpson's 3/8 formula, which is the following. x3 minus x0, so it's 5 minus 0, multiplied by f of x0 plus 3 times f of x1 plus 3 times f of x2 plus f of x3 divided by 8. So take a look at the formula if you want to copy it down first. Okay, now once we press enter, we've successfully utilized the Simpson's 3/8 rule. Now the exact value, or the value you would get from your calculator, is 22.123. However, using our approximation with the Simpson's 3/8 rule, we got the value to be 21.3465, which indicates a 4% error. Now this is why it's important to use a smaller step size. So in this case, we used a step size of 1.7. Now let's try to use a step size of 0.833, meaning we're integrating from 0 to 2.5, and then eventually 2.5 to 5. So we're integrating by parts and then taking the sum of those integrals. So let's just copy down the formulas here. So let's take this and copy down here. And this is just evaluating at these points. So as you can see here. And now let's take the integral. The integral again is just the third point, x3 minus x0, multiplied by the following. F of x0 plus 3 times f of x1 plus 3 times f of x2 plus f of x3 divided by 8. And we can copy this formula down below. And notice that this is just for formatting's sake. It makes it much easier for you also. These cells are merged, and so it's important to do so because in Excel, if you merge these cells in this way, then when you copy down the formula, it automatically integrates from the point you want it to integrate from. Meaning, in the first integration step, we've integrated from 0 to 2.5, and second, we're going to integrate from 2.5 to 5, just making it much easier for you. So make sure that you merge these cells. And once we've done this, we find that the integral of the function is 22.10248, which is just the sum of these two integrals. So the sum from 0 to 2.5, and then from 2.5 to 5. Notice that the percent error is much smaller compared to the original value we got. So in this case, our percent error is only 0.0928. And this is because when we use a smaller step size, the results tend to become much more accurate. Now you might be asking, how do we determine the step size? Well, it's simply just the following. In this case, I just took 5 minus 0 divided by 6. And so when you want to find the step sizes of the Simpson's 3/8 rule, you always divide by 3, 6, 9, 12, and so on. So by factors of 3, like this. So in this case, for example, how we got 0.1 is the following. So it's 5 minus 0 divided by 9, like this. And we get 0.556. Right. This should not, this should be 0.56, like this. Right, since we're 0.56 to 1.11, 1.67, and so on. So again, yeah, you just use that formula. Right, and let's do the exact same thing, but with the final iteration table here. So again, let's just copy down the functions here, and copy down the integral values as well. So let's copy these down here, this, and let's copy all these evaluations like this. And again, we're repeating the same process, so we're integrating from 0 to 1.67, from 1.67 to 3.33, and lastly from 5 to 3.33, taking the sum of all those integrals, and we get the following result, 22.11. Now the exact value, or the calculator value, is 22.123, our approximation is 22.11, and this indicates even a smaller percent error of 0.016, making it much more accurate. And so this is why it's very important when you utilize methods like this that you use a smaller step size. And so this is just a graph to show you what we're doing basically. So this is the curve of 5 plus 3 cos x, and using the Simpson's rule, we're trying to get the area under the curve here that goes from 0 to 0.5. That is it for this video. I do have some other explanations, tutorials on other numerical methods like the Simpson's 1/3, the trapezoid rule, false position, fixed point, and so on. So if you need to learn those as well, or are interested in learning those, please check those out. And yeah, that is it for this video. Thank you for watching.